Hey, what's going on, my students? All right, so we're excited. We got a new unit that we're transitioning to called Writing Inequalities. So, the first thing that we want to basically do is we want to look at the key vocabulary terms that we need to be acquainted with and eventually master through a vocabulary quiz that you guys will see at the end of the week. So, first of all, I want to start with the idea of what does it mean to be greater than? Okay. All right. So, if I were to just simply think about it this, I'm going to use my pen. If I have a number and it's greater than 50, okay, number greater than 50, that's Mr. McCrae's age. What are some numbers that are greater than 50? Well, I could say a bunch of them, right? I could say 51. I could say 101. There's an infinite number of possibilities. All right. Now let's think. There's in word problems, there's more than one way of looking at greater than. So, for example, I could say, give me numbers that are more than 50. Give me numbers that are greater than 50. How about a number that is larger than 50? Or a number that is, here we go, above 50. All right. So they are saying basically the same thing. Okay. They're just saying them in different ways. All right. Let's look at another example here, right? The word less than. So say we're looking at numbers that were less than Mr. McCrae's age. Okay. Numbers that are less than 50. Well, we could say 49. Or we could say negative 101. That's still less than 50. Okay. All right. And again, there are different ways that we can think about it. We can think about uh, a number less than 50. Oops, there it is. A number or a number smaller than 50. Yep. We can say a number below 50. Boom. Or numbers fewer than 50. Boom. We're all gonna no matter how we cut it, we're gonna have the same infinite possibilities. So that's the one thing that we want to talk about. When we think about the differences between equations, they have one solution. When we think about inequalities, they have many solutions, or we like to say they have infinite number of solutions. They just need to be true in that context. All right, so let me clear my screen. Let's think about some more examples. Some more examples. Okay. Ooh, now we get into something interesting. Now we have greater than and equal to. All right. Let's see what that might look at. So let me use let me use another example. Let me use my son's example. We're looking for a number that's greater than or equal to 18. So what are some numbers that are greater than or equal to 18? Well, 18 would fall into that. Uh, Greater than, what about 28? Yep. What about 108? Absolutely. And again, we can say them different ways. All right, I'm looking for a number that is a minimum of 18. Okay, a minimum of 18. 18 is a minimum of 18. So is 228. So is 108. Or what if I said I'm looking for numbers that are at least 18? This would work. This would work. This would work. I'm looking for numbers that are greater than or equal to 18. This will still work. Or, guys, I'm looking for numbers that are no smaller than 18. Infinite number of possibilities. Now let's go the other way. I'm looking for numbers that are less than or equal to 18. Okay, well here, guys, again, solutions. 18 is a solution. 18 numbers that are 18 that are greater than or less than 18. So would 10. So would negative 50. These are all less than 18. And again, we have different ways we can say them. We can say no greater than 18. We can say a maximum of 18. We can say at most 18 or less than or equal to 18. All of these solutions, an infinite number, are still possible. Okay, so let's clear our screen so we can transition from vocabulary to looking at how these problems will actually look. Okay, so let's see here. Let's see here. I have a little Ariana Grande playing in the background. All right, guys, work with me on this in Spotlight. Where's my Spotlight here? All right, here we go, Spotlights. So if I have 8 is less than X, this is kind of how I want to say it. 8 is less than X. Okay, 8 is less than X. My preference, quite honestly, is to write it like this. I like my variables to be on the left and my numbers to be on the right. I'm not sure if Mr. McCrae ever said that. Probably a million times, right? So if I were going to do that, I would say what? X is what greater than 8. X is greater than 8. And what are some examples? Examples for X is greater than 8 would be, how about 10? How about 9? How about 109? These were all true statements. Okay. Make this a little smaller so we can get it on one slide. A little bigger. Okay. Let's take another. And let's take a look at the next example. Okay. X is greater than or equal to 4. X is greater than or equal to 4. Okay. So X is greater than or equal to. I don't know how to do the shortcut on this. Of 4. So what are my examples? My examples would be, would 4 be an example? It would be, because of the rules. 4 would be example, greater than or equal to, all right? 5 would be an example. 105 would be an example of X being greater than or equal to 4. All right, we're going to take a look at 3 more examples, and we're going to set you guys up for your next task. Okay, let's take a look. I have X, all right, and it's really important that we always call it the alligator. The alligator always should be pointing towards what it originally started at. Here, okay, alligator's pointing, or the alligator is trying to eat the X, so we want to keep it that way. So here it says what? X is greater than or equal to 9. So what are our examples? One example would be 9. Another example could be 1,009. All right, these all fit the criteria. All right, let's take a look. X is greater than 9. Now, a number is at least 9. Yeah, I mean, absolutely. 9 is no more than a number. 9 is no more than a number. Not quite 100% sure where they were going with that, but given the fact that I'm the one making the test, I'm going to focus on what I think is most important for you guys. All right, let's take a look at the last one. X is less than, finally got a less than. X is less than 1/2. So what are some examples? Some examples of being less than 1/2. All right, remember our number line? Okay. All right. Would 0 be less than 1/2? It certainly would be. Would any negative number be less than 1/2? Absolutely. So I could get a negative 1/2. Or I could get a negative 1,000. Doesn't matter. Okay. So again, the key takeaway from here is I wanted you guys to think about what my example would be in order to make these inequalities true. Now I want to take a moment and I want to just talk about compare and contrast differences. Let's take a look. What is an inequality and what is an equation? How are they different? How are they similar? Let's talk about that. Okay. So, from the standpoint of inequalities, all right, I think I want to go to my draw key here. Okay. An inequality, right? What is it? Okay. An inequality, typically, we're going to see it this way, not equal. Or we talked about greater than. We talked about greater than or equal to. We talked about less than. And then less than or equal to. These are what we're going to see. All right. An equation, we're going to see an equal sign. Okay. And what are the words that give it away? The words that give it away for equations, there's two equations connected by an equal sign. The words that give it away for inequality is a mathematical statement that shows two expressions are not equal. Okay. So let's talk about what things are not. An inequality is not an expression or an equation. Well, what is an equation not? An equation is not an expression or an inequality. Okay. Well, what is an expression, guys? An expression is something that doesn't have an equal signs or an inequality. So, for example, it might look like this: 18 plus 2x. That is an expression. To make it an equation, boom, put that equal signs in there. Not going to do that though. Let's keep going. Here's some examples. This is what I wanted. Examples of an inequality. 4 is less than 4. Is less than 4. Or guys, we can write it this way too. 6 plus x is greater than or equal to 10. Examples of equations: 5x equals 9, 2x minus 6 equals 10. Now here's the interesting thing, guys. Here's what you and I have been mastering. We've been mastering this. And some of us have gotten very good at it. Well, guess what? We can do the exact same thing with inequalities. Yep, we can. We can do the same thing. Okay? Here's what it would look like for our inequality. We take our inverse, correct? Everything would be the same. The only thing you need to know, and this is something that we're going to talk about multiple times, okay? And I'm going to type it. When you multiply or divide in during or divide our inequalities will flip sides. And what do I mean by flip sides? Let me be clear. If it starts out as greater than and I have to divide, then it's going to become less than. And there'll be some examples that we can talk about as we proceed. But I just want to get that idea out in our notes. Okay, I think we're going to pause right there, and we'll set up our next video.